Python if you wish, but this one is not Python. We're going to use stable-diffusion. Now, before we begin, I'd like to implore you to subscribe, like, follow, and leave comments, because the more people subscribe, the more the algorithm sends it out to more viewers. Those viewers can join this growing community. They can post tips and tricks, or they can post requests, which I can go review, and then I can share with everyone. Everything is already shared here. Alright, now, I forgot to do the intro. Let me see, I gotta pick a nice intro here. Give me a second. What should I pick for the intro? Maximize, fast Wan 2.1, quantized given. Okay, I'll use this one. This is a nice one. Let's put the intro there. Title, here we go. That's it. Okay, back onto the show here. So basically the article will be here. Alright, on to the show. Right, let me see if all the live streams are working. Give me a second. Hopefully they all are. Yeah, all the live streams are good to go. Excellent. Excellent. I like when everything works well, because some of the time things don't work the way I wish they would. Okay, so here's the link. It's on GitHub, legit stable-diffusion.cpp. That's the, you can get the source code. Actually, let's actually go take a look at it here first. So it's legit stable-diffusion.cpp. So this is the one you want. There are downloads. We'll check out the releases. You see the last release was 3 days ago at the time of this recording. So I'll take a look at that in a second, but you can see this is a stable-diffusion.cpp, that's C++, that's what CPP stands for. As you can see, it supports a bunch of models, weights, and you can see here all the supported models, the SD, stable-diffusion 1, the 2 series, the XL, and some 3.5, Flux, Chroma, Z-Image, and what else is here? Image edit models, Flux 1, Quen image edit, the video models, Wan 2.1 and Wan 2.2, Photo Maker, ControlNet, LoRa. LoRa is only for the stable, LoRa support. LoRa support is, LoRa support, I didn't realize that. I thought it was only for specific ones, okay. ControlNet is only for standard division 1.5. And you guys can see this. You can also use the tiny text encoders. You can see all the supported backends. This is the key part here. So if you have a GPU that's no longer officially supported, or you can't get drivers for it, but it still works, this is another app. This could be something for you guys as well, because you can obviously you can use the CPU, you can use CUDA, Vulkan, Metal. So if you're on a Mac with the Apple Silicon, and OpenCL. OpenCL only works for specific Adreno GPUs, and this one I believe this is Intel, or it might be more, I'm not sure. I'll double check on that one. And then you can see other supported weight formats. It supports the PyTorch checkpoints, safe dancers, GGUF models. It's cross-platform Linux, Mac OS, Windows, and Android via Termex, local diffusion you see here. You can have negative prompts. It's limited in the number of sampling methods, and obviously the schedulers. It tries to follow the ConfUI type format, so you can actually use the models from there. That's what I usually do. And yeah, so there you go. You can get executables. That's why I showed you the releases page. But we're gonna go to and there's specific guides as well. So we're gonna go to. I'm gonna open up. You can also run it in Docker. There's so many ways. Rust, Flutter, Dart, C#, Golang. So you can see here, and you can use UIs as well. The only UI I tested, I think, was I tried to do this COBOL CPP, and there was another one for something else. I haven't actually tested that yet, but yeah. So what else is here? You see, it's just one command. You can run it to, if you want to do it in the command line. Now, if you remember, for performance reason, that's why I'm not going to use a GUI. I'm going to run it on the command line just for performance, so you guys can follow along. Oh yeah, this one, stable-diffusion web UI. I haven't tested this one. Does it actually come with it by default? Oh no, this is the stable-web UI style tokenizer. Sorry, I got things confused. Where is the one? Yeah, Wan 2.1. I'll open that as well. So let's go to releases pages. So the release pages, you can see here the pre-compiled binaries. It's cross-platform as well. For example, if you're on Windows, you guys are really spoiled. You have ROCm, that's AMD. You have no AVX. You have CUDA, AVX 512. You have AVX2, AVX for I didn't realize there's two versions now for Linux. This one has Vulkan, and then this one is just for the CPU. You guys have seen me run this before, so I haven't tried the Vulkan one yet. And then for Darwin, you have that's Mac. You have this one, and then you have this one. I guess it means CPU only. So as I said, you guys on Windows are really spoiled there. Yeah, lucky all of you. And here's the changes in this. In this latest version, I said it says 3 days ago, so this is what we're gonna get. I haven't used this in a while, so I'll show you how to update it. Next, we have if you want to build it yourself. Oh, where's the build one? Oh, I didn't open the build. Oh, okay, I'll show you the build as well. Where is the build guide? I thought I opened this. Okay, looks like I did not. Okay, we'll take a look at the build guide. Actually, see here's the if you want to build from scratch. If you don't want to get the binary, you can build from scratch. You can see here, just clone it. Obviously, you need Git. You clone it, or you can get the zip file and do it yourself there. But I prefer Git because that way I can do updates. And then what you do is just CD into it, and then you just do if you're doing an update, you just do the pull. Then you get the submodel. So submodel is for the GGML. And init and update, and then you can build. You can build for CPU only. You can build for OpenBlast. If you're using for CPU only, don't just do CPU. Make sure you get OpenBlast as well. That will speed it up significantly. I did test that. If you have CUDA, obviously, and NVIDIA, definitely run this. You see, you need at least 4 gigs of VRAM here. So there we go. And then HIP+. This is obviously for AMD GPUs with ROCm, etc. So this is the one I use. And then if you move, this is the more threads. There's Metal, obviously on Mac. Vulkan. I tried Vulkan. I also did Vulkan with HIP+ as well. I found ROCm is way faster at this current time. Although Vulkan, it does load up the models really fast. So if I could get the best of those, that would be awesome. And then OpenCL, you see it's for Arduino GPU. And here are the instructions for that one. And then this one, I was right about it's Intel. This is the Intel one. So there you go. I guess the Intel GPU. Yeah, computation on Intel GPU. I was right about that. All right, now we go here. This is Wan. That's what we're doing. You see, you can download the type of models you want. We are interested in this one, the text to image. That's TUV here, and 1.3 parameter model, because remember I'm interested in speed. So you can get the safe tensors, or you can get the you can also use the GGUF version. I'll show you that soon. And you can see you can use other models as well. You can even get the VACE version, and then here, or you can also get Wan 2.2. And so everything is here, and then the VAE file. And then the what else is here? This one is for the 5B model, and then the text encoder. You see, there's this GGUF version, or you can get the just the regular one as well. There's different types as well. It supports a whole bunch of, whether it's a floating point 8, floating point 16, and yeah, it supports all of them. So this is an example here. This is for a lovely cut. So this is what we're going to do. Now you can clearly see this is made for Windows because it's .exe. I have a funny story about this as well. So the naming convention did change. Before it was just SD for Linux, then it changed to SD-CL. I was still running the SD, so I actually had to go and wipe out the and reinstall it. Then I realized, oh, it actually changed that, because I was getting horrible results. So I was blaming the application when it was actually me. I didn't realize they actually changed the naming convention. All right, and you can see some results here for, you can see all the examples, so you can follow along on the command line here. All I said, you can use one of the web UIs. Alright, and then to get the models, you guys have seen this before, I hope I don't have to do this. You go to Hugging Face or wherever you want and you can get the GGUF models. For example, I'll show you here for the text encoder. Come on, to go to the text encoder here. And you can see there's different types of text encoder. You can do that's floating point 16, floating point 32, and you can see floating point FP16 is 11.4 gigs. So obviously, if your GPU is, if you have enough RAM, you can probably get away with it. But I'm saying is that for a lot of us, including myself, I'm kind of limited with RAM. So, and then of course there's also floating point 32. This is full precision at 32 here, but you can see it's 22 gigs of RAM, right? Luckily, this quantized one, you see it says QQQQ here, so you can see. Oh, I forgot to put the vertical screen, so hopefully it doesn't hurt the views too much today. So as you can see here, we have Q3, Q4. You can see they're much smaller. I would recommend if you have the RAM and VRAM, definitely start with at least Q4 KM. That's if anything higher than that is fine. Obviously, depending on what your GPU can support. My GPU natively supports integer 8, so I can run something like this Q8 one. And obviously FP16, FP32, FP64. That's what it natively supports. It doesn't have some of the new features like matrix, but it does support those. So I would definitely, if I was running this, I would get this model. This easily fits inside my the GPU because I have 32 gigs of VRAM. And unfortunately, I only have 32 gigs of RAM, but of that RAM, 4 gigs are used for the integrated graphics. Another 4 gigs is used for something called ZRAM. It's like for swapping. It basically takes the RAM and it compresses, so it gives an extra 8. As I said, so basically I start with 24 gigs RAM, but it's not really 24 because, for example, I'm running OBS. I have this browser open. I have applications opening. So sometimes I only have 21, right? So that's what I'm saying. I don't have enough RAM. So that's why I use the quantized. If you wonder why I use the quantized models instead of the full precision or half precision, that's why. In case you don't know, F32 is full precision, and then F16 is half precision. So this are pretty very good. You don't always need to run F32. F16 is should be your target if you are able to run. See, this one is way too big. Even for me. So then after that we also need VAE. There's only one VAE here. You get it from say confi.org. You can get the VAE there. So we're running at 2.1, so we get this one. It's a pretty small file. I'll open that up and I'll prove it to you. So you can see the file size is only 254 megabytes. So that's pretty small. That should fit in any GPU, even if it's on RAM. It's small enough. So you need the text encoder, you need the VAE, and then we need the model. So remember the model is here. It's a 2.1.3b. So it's pretty small. It's pretty small. So for example, 1.3b, not the base one. I think it should be. I might have to go more here. Oh yeah, here's one for you. See, it's 2.64 gig. This is the BF. So my GPU doesn't support the B part, so I'll get this one. You see, it's only 2.84 gigs. So that with a VAE and a decent one of the small encoders, that shouldn't be a problem. So you can get that one. There's also quantized versions, but at that size, 2.84, that's small enough. I mean, unless you have maybe 4 gigs of RAM or something, that's small enough. You don't need to quantize that one. So where do you put these? So after you download this, I'll show you that. Let's actually go back to the article here. So again, you need to know your GPU. So for example, my GPU is so this model is also open source. It's released under the Apache 2.0 license. The code I forgot to show you guys. I apologize. If we go back here, you see this is released under the MIT license. So everything we're doing today is fully open source. Okay, and yeah, so and there's no restrictions what I'm getting at, right? So you can use it both for personal and commercial video projects. Okay, so my GPU, it's an AMD Instinct Mi60. The problem with it is because it's a server GPU, AMD doesn't support it anymore. That's not a problem. It's open source. The software is open source. I can compile it, everything myself. The problem with it is that consumers, the majority of consumers who have this GPU got it used, like me. I bought it used as well. So what I'm saying is that it's not as popular as, for example, other AMD GPUs or even especially NVIDIA GPUs. So some of this stuff is not documented, so it's like a little bit trial and error. But some stuff is. So for example, these are the flags which, for example, diffusion hyphen conv hyphen direct. This increases the GPG efficiency. It bypasses slow layers to process the video frames faster. So this is one way. I said if you have, especially have an older GPU, it doesn't matter if it's NVIDIA, AMD, or whatever. That's one thing I'm going to use to speed up. I did notice a significant difference without any drop in quality. Another one is to use this one, Cache Preset Ultra. This keeps the weights already in VRAM. This prevents reloading data during the sampling process. So what that will do is, because remember I have 32 gigs of VRAM, and remember the model is actually pretty small, so there's no need to put to load it every time you run something. Keeping it there, meaning that the next run will be faster. And then you can, if you one of the things I noticed was, but the VAE, it was very slow. So you can also use VAE tiling. What this does is it will break it up into smaller blocks to save memory. By default, what it will do is it will the VA is the one that does the encoding and decoding. But this one is not an image to a video. This is a text to it. So there's no encoding there. It's just decoding. So that's always the slowest step. But if you break it up into smaller, or if you break it into tiles, it will actually it will save a lot of memory, and it will be much faster. So you can use this both to what do you call it? If you're running low on VRAM and RAM, if you don't have like RAM, I have a problem with, and also if what I was trying to say is that it tries to do everything all at once, which is not efficient, especially for a non-GPU like mine. So if you could break it up into chunks, that's what the tiling will do. That's layman's terms. And as I told you before, I explained how I only have 24 gigs of system RAM. So this can support the any type of encoder, but also remember also the larger the model, the weight when it's transferring it, because you have to remember the this GPU is not a problem for this type of stuff, but the problem is because it has to load things from the system. That was where the breakpoint will be. If you know what I mean, that's the slowdown. So if you can keep everything in, especially in VRAM, that's why I decided to use this Q4KM, and that fits perfectly fine. That should get you guys running on probably even 8 gigs of VRAM. And I said you can get smaller as well, but you have to remember the smaller you get for especially with text encoder, then it might have some quality issues. All right, so then this is the application I used. It's a parallel downloader. You can use curl, wget, whatever you want, but those ones are single threaded. So I wanted something parallel for faster ones. So I use this one. There's others like the Z. There's actually one, I think that's the one from Hugging Face, but I prefer this one because I don't always download things only from Hugging Face. Sometimes I go to like Civic AI or somewhere else, GitHub. So I want to be able to use something else for that. So that's why I use this one. Now SD stable-diffusion command line, and then you can see you can also specify the Q, like for example Q4K parameter. So that means the quantization maintains the quality while boosting the generation speed as well. And then you can put this cache, easy cache, the cache mode, setting it to redundant, reduces math calculations. This reuses previous results to finish the video sooner. So for example, if I want to change the prompt, everything else is going to stay the same, like the resolution. It doesn't make sense to then have it regenerate the the kernels to run it again. So if it's cached, it'll be much faster. And then I put a flow shift of 3.0 to improve the motion consistency. This ensures your lovely cut video looks smooth and natural. So with that said, I have before here I have a special partition I called AI partition. If you notice a few things in here, this is the conf.ui folder, and this is the stable diffusion folder. So let's go through the conf.ui folder first. This is where I put the models, and let's go to the models here. So you can see here, I'm gonna go to the VAE. You see here we have the 2.1 VAE safe tensors. That's where they go. And next we have the unit here. And you can see I have this guy here, the 2.1 text to video 1.3b. I'm using the Q4 one as well. I could have used the FP16 as well, but I'm going to use Q4. I've done testing before, and I found that the fastest model for me, for my work, from this GPU, is the integer 8 or Q8. That's the fastest. Now, if you read everything, and in theory, FP16 should be the second fastest, but it's actually not. This Q4KM is always the second fastest, and then barely faster than FP16. So instead of loading a massive model, although it's not that big, it's only 2 point something gigs. You see that I prefer this one. It's 1 gig, so it'll fly, it'll fast. I already tested. I think I did a night stream where I tested all of them, and I found out that this is the sweet spot here. Obviously, Q3 or Rev will be faster, but then there's a quality degradation. And then what's the other one we need? We have, the text encoder. So we have to go to text encoders, text encoders here. And you can see we have, I have the Q8 here, and I also have this way. So the Q8 is 6 gigs, and the Q4M is 3.4. So yeah, so again, that I said if you get those type of models, they should be able to fit in 6 gigs. Maybe you might even be able to squeeze it if you have enough RAM in squeeze in 4 gigs as well. So now with that said, so that's our, I put everything in conf.ui because I also use conf.ui as well for now. Now we have, I have this application, so I'll run this application. This is the cooling because the GPU didn't come with cooling. So I got a fan shroud and I got a 40mm fan, so that's how I manually control it. This is the stable diffusion folder. So I just basically git clone and I put everything in here. And this is the build folder. So I'm gonna start actually right here when we go to the command line. Just want to show that to you guys. So I'm gonna open up a console. Put the console here. Okay, and we'll go there just to get started. So back here, do I need anything else? This is just screenshots, so we can just go through that. And this is a live stream. The console. Okay, as you can see, it's a live stream. All right, so back here. So now I'm going to do a few things here. I don't need this one here. So what I'm going to do is I'm going to, why did you do that? Jeez. I'm going to fix that by now. So I'm just going to start up the cooler application. Okay, so the cooler application has started. Now I'm gonna go here and I'm gonna go to stable diffusion. What I'm gonna do is I'm gonna look for updates. So let's see here. All I have to do is do a git pull. There should be some updates. Yes, there are. So see, there's some updates. I was a little bit behind. I didn't have. There's 2 of them. So I was on 469. You see, I pulled in 470 and 471. So these are the changes here. And then, so that's from the main repository. But remember, there's sub models. So to get the sub model, let me zoom in here so you guys can see. To get the sub models, let me actually clear this. Clear. Okay, to get the sub models, you just type git sub module. Sorry, update int recursive. Recursive. Okay, so there's been an update in GGUF as well. Okay, I didn't expect that because there's only been 2. This is the second time there's been one as well. So I'm happy with that. All right, so now you go to the build folder and you just type in those commands from before. They're always the same commands. It's the first of all, you have to make sure ROCm is available. So I'll show you that. You see ROCm. It found ROCm. This is from the Fedora repositories. Then my GPU, let's see if it detects the GPU. Yeah, GFX 906. Okay, then you just, this command is exactly the same. I did make a few changes to this command, and I'll show you what I did. It's the same one right from the GitHub page. If you notice here, I'm using Clang, of course, +1, and okay, I think I might have uninstalled, what do you call it, Vulkan. I might have uninstalled Vulkan because it was detecting Vulkan and also building for Vulkan, or you can just put Vulkan off here as well. So that's a command. This command is copied right from the from the GitHub repository. So everything here is perfectly fine. Yeah, so you see it's also adding the CPU backend. I don't know why, but okay, whatever. So this is fine. Now, then all you have to do is just do the build and release. Okay, so you see this git commit, that's the latest one. We just grabbed it literally a few seconds ago. You can see everything is here. So it should run. Now, what I've found is that GCC is more accurate in some of this C++ variables, but obviously AMD uses Clang, so we use Clang. So hopefully this version of GGML won't produce some warnings. We'll see. I expect them to be warnings. GCC is pretty good with this. So you can use GCC or you can use Clang. I used to use GCC in the past because I already had it in the system, but there's some things also where I need Clang now, so that's perfectly fine. Usually after 100 it will start, you'll see some of those warnings. You can ignore them. As long as the build finishes, that's what we care about. So we'll let this guy go. I'll zoom out a little bit. So I can hold the control key. There we go. I'll hold the control key. Zoom out just a little bit so you can see what's going on there. Wow, I'll be surprised if it actually finishes without any warnings. It's taking a little bit longer than usual, but I'll just be happy if there's no warnings, but I seriously doubt it because Clang always has some warnings, but we'll see. Though usually in the GGML backend, I'm wondering if they've resolved all those warnings. I'll actually be really happy if they have. Yeah, no, I was wrong. Yeah, no, I was not wrong. I was right, you see. There's still those warnings. They can ignore them. You see, they're using some literal, as you can see, those are all warnings, but it's still building. That's the most important thing. Usually it starts at 100, so I'm guessing there's still some things. Most of this go away if you actually use GCC for compiling, but that's fine. It should be finished soon. Yeah, there we go. It's done. You see, this is the part that I didn't, yeah, because I was still using the old CD only, but it's CD-clear. So if we go into our stable diffusion folder here, go to the build. If we go to the bin, you see it has this one and the server. I haven't used the server yet. Before it was only one file, CD. Now it has this to split them up there for the command line and then the server one. Alright, I'm guessing the server one might be maybe for some future web UI or something, I'm not sure. Or maybe it's for to plug into a remote client or a third-party client. Alright, so now we can actually start generating something. So let's go back to here. And you can see I did generate, obviously this is not it. See, I already generated some videos. So I'm going to I'll show you the command I'm going to run to generate another video. We're going to make it number 7 and then we'll play it. But before I do that, I need a web browser in order to start the fan on the, yeah, so I need this. So basically, this is I have a AMD Ryzen 5 1500 GT. This is the GPU. So this AMD Instinct Mi60. It's 32 gigs of VRAM, and this is the integrated graphics. Oh, remember this? I'm like this. So this is integrated graphics, and this is the Wi-Fi card. The Wi-Fi card does come with the cooling. But the reason it shows up here because it has a sensor, it has a temperature sensor. So system fan 2, you see right now this dedicated GPU, it's running, the fan for it is running just below 3000 RPMs. So what I usually do, I put this about 35 for noise. 35, that should be fine. I'm actually going to start that so it's not too loud. I'm going to clear this here. Alright, and I'm going to show you my prompt, and actually, you know what, I think, yeah, I'll show you guys my prompt. It's not a big deal. And I'll run it, I'll paste it in here. So as you can see, bin, it basically goes in that bin folder. This one, oh, come on, bin, this bin folder, I showed you this, the cd -cli, and then the models, we're going to do video generation. You can see it's going to grab the diffusion model from the UNet folder, and you can see which one we're grabbing, the Q4KM GGUF. The VAE file, it's the Wan 2.1 VAE step sensors. Then the text encoder, it's the text encoders, and you see it's a Q4KM as well. And then our prompt is a lovely cat, and the SVG scale is set to 6. The sampler method is Euler, and this is -v for verbose, meaning to put more stuff out